idea of what we're doing here, let's let screen load up, is we're building what's called a factor tree. That's kind of the starting point of all this. So your factor tree is with prime numbers 2, 3, 5, 7, 11. You may not need to go up much past that. So we'll start with number 3 here. Square root of 72. And you start out by asking, what does 2 go into 72? Is 72 divisible by 2? And it is, it's even. Okay. And then you try 2 again. You're like, okay, well, does 2 work? Yeah. 2 and 18. Then you try 2 again. Does 2 work? Yeah, it's 2 and 9. But does 2 work with 9?
No.
Does 2? No. So you say, okay, well, I've used up 2. Let me see if 3 works. Well, it just so happens that 3 does work here. 3 and 3. Okay. So notice there are prime numbers around the edges here. You're looking just around the edges. So after you build this factor tree, you then circle pairs. So a pair of 2s and a pair of 3s. For each pair, you can bring a number out. If you don't have a pair to go with it, you leave it in. So your answer takes on the form stuff on the outside, stuff on the inside.
Okay.
So in your problem, the 2 comes out and the 3 comes out. You multiply those together. Okay. And then on the inside is the 2.
Okay.
Now we're going to do a bunch of these, so to get comfortable with it. But any questions so far on that?
No.
Your final answer is 6 square root of 2. You do have to actually multiply those on the outside.
Okay.
All right, so let's look at let's look at number 4, square root of 45. All right, so again, 2, 3, so on, prime numbers. Does 2 work? Does 2 go into 45?
I would say yes.
It's only if it's even. Is 45
Okay.
even?
No.
No, it is not. Okay, so 2 does not go in. Does 3 go in?
Yes.
3 times what gets you to 45? Or 45 divided by 3?
Let me see. Be quicker. 15.
15. And then you try it again. Something works, you try it again. Does 3 go into 15?
Yes. That'll be 5.
So you stop when you have all primes on the leaves.
Okay.
Or on the outside. So these are all primes. You circle pairs. Do you see any pairs here?
3 and 3.
You circle those pairs. That means you're going to bring a 3 out. Is there a pair of 5s?
No.
So that stays in. So your answer is what goes on the outside, square root. Sorry, that's not written well. Square root of what goes on the inside.
It'd be 9, and then
No. You bring a 3 out for the pair.
Oh, okay.
The pair becomes a single.
Oh, okay. 3 and 5. Okay.
3 square root of 5. All right,
Okay.
we're gonna do a bunch more here, but are you comfortable with what we've done thus far? Okay. We're gonna do number 5 next. 5 is the square root of 128. What is the smallest prime number? Josh, what's the first one we should always start with?
2.
2. 2 times what? What's 128 divided by 2?
64.
64. And then you try 2 again.
64. 32.
And then you try 2 again.
2. 16.
Okay. You try 2 again.
8.
Keep going.
8 and 4.
And
All the way
2.
to 2.
All right. So you got to still circle pairs.
Okay,
There's a pair. There's a pair. It doesn't matter where you start. You'll get the same answer. How many pairs of twos do you have?
3.
3. So you bring a 2 out for each of them. 2 out, 2 out, and a 2 out. So it's 2 times 2 times 2 on the outside. What's left on the inside?
It would just be a 2.
Yes. So what is your final answer?
8, and then square root 2.
Good. All right. I'm going to have you try number 6 on your own.
Mhm.
You can ask me questions if you need, but this one is completely doable.
So it would be, yeah, let's write this down. Okay. So the answer would be 3 on the outside and 3 on the inside.
So 3 square root 3 is how you would answer that.
Okay, 3
Good.
square root 3. Okay.
Good. Okay, before we do number 10, we want to talk about the divisibility rule for 3. Because the rule for 2 is straightforward. It's even. If it's even, it's divisible by 2. Do you remember for the divisibility rule for 3? Did you ever hear that before? It's okay if you haven't, I'm just asking.
I don't think so, no.
All right, so you add up the digits.
Okay.
Okay, so let's look at the square root of 175 and let's add up the digits. 1 plus 7 plus 5. What does that add up to?
The 13.
13. Is 13 a multiple of 3?
Yes.
It is. 3,
No.
6, 9, 12. No. So if the digits add up to a multiple of 3, it is divisible by 3. So this one is not. So notice like you normally start out with 2 and then 3. What's the next prime number after 3?
Either 6.
6 is divisible by 2 and 3. Prime numbers are only divisible by 1 in themselves.
So 4.
4 is divisible by 2. It's also even. 2 is the only even prime number.
Hmm. 5. Okay.
What is the divisibility rule for 5?
I would say it would be the same thing. Just add up.
So it's different. I guess you've not seen this one before. You look at the last digit, whether it ends in a 0 or a 5, it's divisible by 5.
Oh, okay.
So this one is divisible by 5.
Mhm.
All right, so why don't you continue the problem from here and let me know what you come up with.
So I'm supposed to. Oh,
Keep going. You're supposed to find the 175 divided by 5.
oh, okay. 35. 5, 7. So it'd be 7.
35. And then you keep going. Does 5 work in 35?
Mm-hmm.
Okay, what does that become?
7.
5 and
5 and
7.
7.
Okay, so what's your final answer? What do you have any pairs? What's coming out? What's staying inside?
5 is out and 7 is inside.
So give me kind of read to me the final answer. So this one up here was 3 square root 3. What is
That
this
would
one?
be 5 square root 7.
Good. Good. Okay, now let's look at 11 here. Square root of 450. Is this number even?
Yes, I would
You
say.
seem uncertain. Let's talk about it. Even ends in 0, 2, 4, 6, or 8.
Mm-hmm.
0, 2, 4, 6, or 8. If it ends in those numbers, it's even. So yes. What's 450 divided by 2?
225.
Good. Is 225 divisible by 2?
No.
It is not. Now, what was the rule for 3? What did the digits have to add up to?
Let's add up to 3, I think.
A multiple of 3.
A
So
multiple of 3.
what is 2 plus 2 plus 5? What does that add up to?
9.
9. Is that a multiple of 3?
Yes.
Okay,
I think so.
it is. 3, 6,
Yes,
9.
okay.
So this works here. So 3 and what number?
That would be 2, 75.
75. Now you try it again. Is 75 divisible by 3? What is 7 plus 5?
That is 12.
12. That's divisible by 3. So
Okay.
we know 3 works again.
75. 25.
Okay. Where do we go from here?
I would say plus 2 plus 5. We've been doing
Well, so it is not divisible by
3.
3 anymore. So what's the next prime number after 3 to try?
That'd be 5.
5. All right. Now we've got all prime numbers on the leaves. What do you
So
see any pairs?
3 and 3.
Okay. Any other pairs?
No. Oh, 5 and 5.
Yes.
2 5s and 5.
So what goes out? What stays in?
3 goes out and 5 stays in.
But there's a pair of 5s. Don't the pairs come
Oh.
out?
I would say yes.
They do. Pairs come out.
Okay.
What
So
stays in? What's left over that's on the leaves?
5. Another
We've
5.
circled the 5s.
Oh,
That
2.
2. Yeah. So sometimes it could be up at the top. You got to scan through the entire list.
Okay.
All right. So what goes on the outside?
That would be 15 square root of 2.
Perfect. Well done. All right.
Okay.
I'm going to have you try 14 on your own here. Square root of 80. Just give me the final answer whenever you're ready.
Okay. Okay.
What do you
Answer would
got?
be 16 the square root of 5.
Okay, so I agree with the square root of 5 part.
Would it be so then what times 4?
Let's do it this way. Tell me what you did first. What went in your first branch left? What's branch left here?
2 and 40.
Good. And now what's your next branch?
2 and 20.
Good. No problem so far. 2 and 10, 2 and 5. Does that look right?
Mm-hmm.
Okay. Did you circle a pair of 2s?
Mm-hmm.
So what comes out?
4. Or that would be
Uh,
2.
Be a 2 comes out. What about this other one? What comes out?
2.
Okay. So what goes on the outside? 2 and 2.
Oh, so that would be 4. Okay. Okay. Okay, so 4 square root of 5.
Yes. Yes. Very good.
Okay. Okay.
All right, so I'm gonna have you do one more on your own here before we move on to some new stuff, kind of new.
Mhm.
Square root of 432 for number 12. If you're not using a calculator, please do to check that it's divisible and all that. But let me know what you come up with. How are you doing on this one?
Not too hard.
Okay. I'm gonna just step away for 30 seconds, but I'll be right back.
Okay.
All right, I am back.
Okay.
Let me know when
So
you got your answer.
I have the answer.
What do you got?
For the square root of 3.
Okay. So here's how I check your answer. I square the first number, multiply it by the one underneath. This is 16 times 3, which is 48, which is a little bit small. Let's go through this together. 2 and 216. Does that look right to you?
Mhm.
2 and 108.
Mhm.
2 and 54.
Mhm.
2 and 27. Now 27 is not divisible by 2 anymore. So it's 3 and 9. 3 and 3. So I know you
Oh,
circled a 2 and a 2. Which pair did you miss?
I missed the bottom one.
Yes. So how does that change your answer?
Okay, that would be the number 2, 2, 3. It would be 12 square root of 3.
Yes. Very good.
There we go. That was number 12. Okay.
All right. We're going to look at 15 and 16 together here.
Mhm.
All right. So 15 says 7 times the square root of 81. So you're literally multiplying 7 times whatever the square root of 81 is. This is a nice number. It's 9. So it's 7 times 9,
9.
which is 63. Okay. The one on the right, 3 times the square root of 16. What is the square root of 16?
4.
It's 4. 3 times 4 is
12.
good. Now, these get harder. So we're going to look now at 19 and 20.
Mhm.
Do you know the square root of 32? Like, is it a nice number?
I would say yes.
Okay.
Yes.
This is not a known one. Square root of 36 is known. Square root of 25 is known. This is not known. So we
Oh,
have to take just this part. Let me, just this part here, and we've got to reduce that.
okay.
We'll deal with the two later. So this is 2 and 16, 2 and 8, 2 and 4, 2 and 2. And you circle pairs again. Pair, pair, no pair. So what does the square root of 32 become?
4 square root of 2.
Very good. So if the problem becomes 2 times 4 square root 2. The square root of 32 is 4 square root 2. You take the 2 and you multiply it by the 4. So this becomes 8 square root of 2.
Mhm.
So your focus is basically on the root part, and then you take whatever you get in the root part and multiply it by this out in front.
Okay.
Okay, so I'm going to leave this up. I'd like you to try 20, ask me some questions, but your focus has to be on the square root of 40. You have to be able to reduce that like we've been doing now.
Okay. The answer would be the 2 the square root of 2.
No way. No way. Too small.
Too
So
small.
you're not circling a pair, or you're missing something.
It would be 5 then.
What's your final answer?
I have 1 pair 2, and then 2 and 5 at the bottom. So it'd be from 20, 10, and 5.
Okay. So you've got a pair of 2. So I agree that comes out. What does not come out? What has to stay in? The 2 and the 5. I guess we've not
Mhm.
seen this. They multiply each other inside.
Oh, okay.
So if there's no pair, they multiply together on the inside.
Okay. So then that would be this 2 the square root of 10.
Yes.
All
But
right.
that's just the square root of 40. You have to bring this 5 down and multiply.
Okay. So then that would be 10 the square root of 10.
Yes. All right, we're really close. I gotta have you do one more though to really get this down. So let me have you try this one. 8 square root of 80. Go ahead and try this one, please.
Okay, so the correct answer.
What do you got for me?
32 the square root of 5.
You're awesome. Well done. Okay. We're going to move now to a new style of question. Like we're slowly inching our way through this thing. But we're doing it in a way where you're probably understanding. So I'm going to give you some problems here, and I'm going to tell you the answer. And I want to see if you can detect the pattern. Okay. So the square root of x cubed is x square root of x. The square root of x to the 5th is x squared square root of x. The square root of x to the 9th is x to the 4th square root of x. The square root of x to the 29th is x to the 14th square root of x. And what I'm basically wanting you to see the pattern between is this number here and this number here.
Mhm.
I can give you some more if it will help. This isn't math. This is like pattern recognition. So it's okay if you're not like able to do it. It's just, it would help if you could see the pattern. Like, what's the rule to go from the number out here to this number, which I guess I didn't even write it.
Subtract by 2.
Okay, so that works for the first one. Does it work for the second one?
No.
No, so you got to do a different rule.
Hmm. Divide, maybe.
Okay. You said the two correct words. There's a subtraction component and a divide component. Let me know if it's still unclear. We'll look at something a little bit easier and then come back to this.
Yeah, I'm pretty confused.
Okay, you're going to get it. Square root of x to the 4th is x squared. The square root of x to the 10th is x to the 5th. The square root of x to the 48 power is x to the 24. What is the rule? How are we going from this number to this number?
We're dividing by 2.
Dividing by 2. Okay. Now, let me pull up. I'll keep that up here. So let's look at the square root of x to the 5th. Okay. This is really the square root of x to the 4th times x to the 1. Do you agree with that?
Mhm.
Which is the square root of x to the 4th times the square root of x. What did we say the rule for this one is?
You
You just did it up here.
It's division.
Division. So this becomes x squared times the square root of x.
Okay.
Okay, so let's do another one here. Let's say it's x to the 9th. This is really the square root of x to the 8th times x to the 1. Do you agree with that? Do you see how I got that exponents?
Mhm.
The square root of x to the 8th times the square root of x. What is the square root of x to the 8th?
That would be divided. That would be x4.
x4 times square root of x.
Huh,
Okay.
okay.
Now here's what we're doing. We're going down by 1. So how do we go from 5 to 4?
We subtract by 1.
And then how do you go from 4 to 2?
We divide by 2.
9 minus 1 is
Subtraction
8. And then divided by 2 is
4.
So let's go back and look and see if that works. What is 3 minus 1?
2.
Minus or divided by 2 is?
Oh, 3 divided by 2
No,
is 1.
yeah. Let's try this one. 5. 5 minus 1 is?
4.
Divided by 2 is?
2.
Okay. How about 9? 9 minus 1 is?
8.
Divided by 2?
4. Okay, I'm getting it.
29 minus 1?
28.
Divided by 2?
14.
All right. So there's two ways you can do it. You can use the rule, or you can break it apart like this. Which do you prefer?
I say, since I don't fully understand it, or it's just new to me, I guess this breaking it down,
Good.
and then when I
Yeah.
get used to it, yeah.
Okay. So let me have you try one here. Let me have you try the square root of x to the 17th. I want you to tell me what the final answer is, breaking it apart like we do here.
Okay. Okay, so I have the answer would be x to the 8th power times the square root of x.
Good. Okay, we're gonna try problem 21 now together.
Okay.
You're doing great. Hopefully you're understanding this.
All right.
All right, 21 says square root of 12 x cubed. So this is really two problems in one. It's really what is the square root of 12 and what is the square root of x cubed? So the first part of our lesson, like the first 26 minutes, we were doing problems like this. The last 8 minutes, we've been doing problems like this. You're combining the results now.
Okay.
All right, so I want you to do the one on the right. I will do the one on the left.
Okay. So the answer would be for x cubed would be x square root of x.
Good. And then the 12, we'll just break this apart here. 2 and 6, 2 and 3, pair of twos, it becomes 2 square root of 3 times x square root of x. Okay. Is that clear how we kind of did each part of these? I mean, you did the one on the right, I did the one on the left.
Mhm.
You combine the parts that are outside the root and you combine the parts that are inside the root.
Okay.
So if it's outside, it stays outside. If it's inside, it stays inside.
Uh-huh. Alright, okay. Yes,
All right.
okay.
You kind of got it, maybe.
Mhm.
All right.
No, I got it.
Well, we're gonna see if you got it. There's always another problem here to do. I like the confidence though. All right, why don't you try number 22 on your own? It's just like the last one.
Okay. Yeah. 2, 5, 4. You have to do 18 as well, right?
Yes, you have to do both.
Okay.
You look at it as square root of 18 and square root of y to the 5th. You do them separately and combine the results.
Mhm. Okay, let's see if I have it correct.
Yep, good. Whenever you're
Yeah.
ready.
Answer would be 2y squared square root 9y. I don't know if that's
Sorry,
correct.
I heard 2y squared square root 9y like that.
Mhm.
Okay, so a couple of issues. The issues are with the number though, not the variables. So the variable you got right, y squared square root of y. This is 2 and 9, 3 and 3. What's the pair?
3 and 3.
Yes. So what should come out?
Oh, okay, that's what I made a mistake. Okay. I put 2. I thought 2 would come out. Okay. So then 3 would come out. So let me replace it. I think we keep 9. Yeah. So then it would be 3y squared square root 9y.
2. The 2 stays in.
2 stays in. Okay.
2y.
2y.
So the pairing here, I mean, this is the key, is it becomes, sorry, that didn't move right. Let me get rid of that. So the one on the left becomes 3 square root of 2 times y squared square root of y. You combine the parts outside the root,
Mhm,
square root of the stuff that's underneath.
mhm, mhm.
All right,
Okay.
let's have you do another one here. Let's do square root 108 x to the 11th.
Okay.
Go ahead and give that a try, please.
Okay. Let's see if I have the answer.
Okay.
Okay, so it would be 6x to the 5th power square root 3x.
Nice job. All right. Okay, so we're going to move on to some higher order problems.
Mhm.
One of the thoughts I have here is that sometimes we have like a task in front of us, and we know what we need to do. We just don't want to do it because there's so much to do. And that's kind of what's about to happen here. It's like the problems get bigger. You know how to do everything to do these problems. You just may not want to do the individual pieces. Like this is the square root of 25. This is the square root of x squared, and this is the square root of y cubed. Individually, you know how to do each of these. It's being able to do them all together and then pair up the answers. All right.
Yeah.
And that's really the challenge here. It's not that these problems are difficult. It's the combination of the combining of them. Square root of 25 is 5.
Mhm.
The square root of x squared, because it's even, it becomes x. Okay. This last one here, what does the square root of y cubed become?
Y, I would say y to y cube, y squared. No, y, just y.
Y square root of y.
I'm thinking.
Is that okay? Clear?
Mm-hmm.
You've done a
Okay.
bunch of these. That's why I'm kind of going through it a little faster. 5 times x times y are all on the outside. They squeeze together. 5xy on the inside.
Mm-hmm.
So let's look at another one here together. This, much like the last one, is 3 separate problems. 4 actually. It's the square root of 36. It's the square root of x cubed. It's the square root of y cubed. It's the square root of z to the 6th. Can you tell me the answer to any of these individual ones?
Let's see. Then 36 would be 3.
36 is 6.
Oh, 36.
Yeah.
Then 3 cubed. I would say that would be x. No,
Square root of.
x.
Okay. How about the next one?
Y square root of y. Then z squared.
Yes.
Okay. Yeah, okay.
Great. So now you got to piece it all together. So you have parts that are outside the root and parts that are under the root. Does the 6 go inside or outside the root?
Outside.
Okay. Does this first x go inside or outside the root?
Outside.
Okay. How about the next x?
Inside.
How about the first y?
Outside.
And then the next y?
Inside.
And how about the z squared?
Outside.
Yes. There's your answer. All right. So here's what we did not do today, because I think you're owed that. We did not do any cube roots, 4th roots, 5th roots, etc. I consider these higher order, so I wouldn't touch any of those until we've done all of these. But you know enough now to try like 27, 28 on your own.
Okay.
The other ones we would really want to do as part of another session, may or may not come up on a test or a quiz, but they're similar, but it's like, you know enough to do these really well, but I would stay away from these for the moment, or go check out my YouTube channel or other YouTube channels to see what they have to say on these, but they're related. They're just a little bit harder.
Okay.
So it looks like we're doing like 1 lesson section per week. I hope that's good for you. I think you're doing great. You're doing a bunch of problems on your own today. So well done. We're going to go ahead and
Thank
stop
you.
here for today.